Welcome you all to this lecture. Today we start continuous random variable. So this is your chapter number 3. Chapter number 3, which is continuous random variable. So in chapter number 2 we discussed the discrete random variable. Here we discuss the continuous random variable. So normally when we discuss continuous random variable, so we discuss some intervals. So we say that if you have small brackets like that, it means that this is an interval. So this is known as open interval. Similarly, if both are square brackets, so this is known as closed interval. Because in continuous you have a lot of numbers within two numbers. So in discrete you have a discrete numbers, but here you have the continuous values. So that's why we need this intervals to define values. So we do have intervals like this, close from x and open from x2, or we do have another that is open from x1 and close from x2 and so on. So this is some relation that we have when we discuss the continuous random variable. Now before that, next thing that we have to discuss is that in continuous random variable, the probability of each individual outcome is 0. So this is a unique this is only true for continuous, because you have lot of number within a number. If you go with just for one point, then in that case this is 0. How? Let's consider an example here. So example is students arrival time between say 7:55 to 8:05, okay, in the campus. Okay, now if we say t is a random variable and we say that it's related to 8. Now we say that okay, range of t is between t such that this is -5 less than equal to t is less than equal to 5. So we have a margin that either student comes around 7:55 or up to 1. And now if we want to predict if we want to predict the time student arrival time, so this is the range, but we exactly want that what is the time. So the more precise the prediction is, the lower the chance it will occur. Okay, it will be correct. because if we further reduce it, so if I go to the next thing, so the more precise the prediction, the lower the chance of correct correctness. What do you mean? Means that, so if we say okay, t is between 1 and -1, now this means that we are looking, okay, how many students came at 59 to 801. So as we reduce the gap, that timing range is, so it's very difficult to exactly know that we get the correct. So if we further smaller it, for as we okay, let me rewrite this, sorry. Okay, so if the prediction is more precise, so if we want more precise prediction, so this means that we have to further smaller this region, the probability that it will be correct gets smaller and smaller, because we are reducing the overall interval smaller, eventually 0 for fixed time. So this means that at a fixed point in continuous case, the probability is 0. Now continuous random variable is that the amount of probability in an interval gets smaller and smaller as the interval shrinks. We refer to probability density function Because the idea is that in discrete case we define the probability mass function. Now here we look at the density, how dense it is, function to describe probabilities related to continuous random variable. Now the main idea is in continuous random variable, probability at a fixed point is 0. For that case we define the continuous random variable. Now we look at 3.1, and this is the the cumulative distribution function. Now we have a definition, that is 3.1, and this is CDF, and so CDF of continuous random variable is equal to probability x is less than equal to x. So this can use to represent the random variable. Now there is a theorem, that is 3.1, and theorem says that for any random variable, say x, this is the same that if CDF at minus infinity is 0, we know that CDF at infinity is 1, we know that, and lastly is that probability x1 is less than x is less than equal to x2 is actually equal to CDF of x2 minus CDF of x1. Okay. There's another definition. Definition is 3.2, and it says that continuous random variable x is continuous if the CDF, that is f x of x, is a continuous function. Now question is how you find that this is a discrete random variable or continuous. So what you have to do, you have to look at the CDF. So if CDF is a continuous, so this means that your random variable is a continuous random variable. Okay, now let's do a quiz here, quiz 3.1, and quiz says that the CDF of a random variable y is given to us as fy of y is equal to 0, y by 4 and 1. 0 when y is less than 0, and between 0 and 4 y is y by 4 and greater than 4. So this is the CDF given to us, and he says sketch the CDF of y and calculate the following. Now for sketch, so first of all let me sketch it. So assume that this is 0, this is 0, assume this is 4 and so on. So this is values of y and this is CDF y of y. At 0 is 0, okay. After 4 it's 1, so let's suppose this is 1. If I say this is a value of 1, okay. Now in between this let's suppose this is 0, okay. Now between this we have to make this function y by 4 with the fourth is the intercept. So assume that if y is 0 it is 0, y is 1 it is 1 by 4, if y is 2 it is 1 by 2. So if I make the 1 2 3 4, so if this is the half, so at half it will pass from here. So if I draw a line, this will make the CDF look like this. Okay. So this is the line y by 4. So this is the CDF. Now question 1 is calculate the probability that capital Y is less than minus 1. Now as know this is the definition of fy of minus 1. What is value of y of minus 1 is 0. Now if we look at the second question says that calculate the probability of capital Y is less than equal to 1. Now we know that the definition, this becomes f of y of 1. Now we plug in here for this formula, that becomes 1 by 4. Now third one says calculate the probability that y is between 2 and 3. So we apply the theorem, and theorem says that this is equal to fy of 3 minus fy of 2. Now plug in the values for 3, it becomes 3 by 4 minus 2 by 4, so it becomes 1 by 4. Now the last one, we have to find the probability that capital Y is greater than 1.5. Now for this, what we have to do, we have to convert it that it is 1 minus probability of capital Y is less than equal to 1.5. So this is the CDF definition, that is 1 minus fy of 1.5. So let's plug in 1.5, this becomes 1 minus 1.5 divided by 4. Now when we solve it, becomes 5 by 8. So this is the answer for your quiz. Now article 3.2, that is probability density function. Probability density function, we normally called it as PDF. So we also call it as PDF. Now for probability density function, what we first of all we need to look at the definition. So definition is 3.3, and it says that the PDF of a continuous random variable x is defined as small f is subscript the random variable, and in bracket small x is equal to derivative of fx of x divided by dx. So PDF is actually the derivative of CDF. Okay, now there is a theorem, and the theorem is 3.2, and theorem says that for a continuous random variable x with PDF f x of x. Okay. First one is that PDF f x of x is always greater than or equal to 0. That is for all x, because this forms the first axiom of probability. Second one says that if I want to calculate the CDF from PDF, what I have to do, I have to integrate the PDF, that is f x of u du. And last one is that, and this is very important, if I integrate from minus infinity to infinity of CDF, this is equal to 1. So this is all actually from the basic axioms of probability. Now if we move, next one is the theorem. Theorem is 3.3, and theorem says that if you want to find the probability that x1 is less than x is less than equal to x2, this can be easily calculated by integrating from x1 to x2 of PDF. This will give you the result. Now let's do an example here. Example is 3.4. Example says that for an experiment, the PDF of x and probability of the event, taking the derivative CDF in equation this, okay, let me go to example 3.1. Okay, so in 3.1 example, okay, 3.1 example, let me write from 3.1 example 3.1. okay, so we have fy 1 by n, y is 1, 2, so on, 0 otherwise. Okay. PMF is given here, so there is no PDF. Now if we look at example 3.2, 3.2 give us CDF. So CDF is given as fx of x. So this is better, 0 x 1, x is less than 0, and this is between 0 and 1, and it is greater than or equal to 1. Now to calculate the PDF, so what we have to do, that we have to do the differentiation. So as we know that the formula for PDF is the derivative of CDF. So let's do for this one. So f x of x means 0. So take the derivative. So let me rub here. Take the derivative of x. So when I take the derivative of x with respect to x is becomes 1. So it is between when 0 is less than x is less than 1. And when I take the derivative of 1 or 0 is 0. So it is 0. Put it otherwise. So this is the solution. So if I draw it, so this means that this is between 0 and 1. So this is 0, this is 1, your x, and this is your 1, x of x. So let's move to next one. So there's another example. An example is 3.5. An example says that consider an experiment that consists of spinning the pointer and 3 times and observe y. So CDF is given to us. CDF is this, that is 0y cube and 1. So 0 as y is less than 0 and between y is between 1 and y is greater than 1. Okay, so if I plot the CDF, so if I assume that this is 0 and this is 1, so this is a third order, so it will, for example, this is 1, it will, so as you know that this is a continuous CDF, so this means that this is a y is a continuous random variable. Now if I calculate the what you say PDF, so for PDF what we have to do is that take the derivative, so we have to take the derivative of y cube here, that becomes 3y square, between y is between 0 and 1 and otherwise is 0, because the derivative of 0 is 0 and constant is also 0. So if I plot this one, so CDF look like assume this is 0, this is 1, so it look like 3y square. So if this is 1, so it will go like this. Okay, so the value you get here is 3. So this is CDF. Now if we move further and we discuss how we calculate, now let's do an quiz and then we will move further. Now on next page we will do quiz and then we discuss the expected value. Now quiz is 3.2, and quiz says that we have a random variable, that is x, has probability density, so this means that this is a continuous random variable, as PDF given as f(x) of x equal to cx power exponential x by 2 and when x is greater than or equal to 0 and 0 otherwise. Now he says sketch the PDF and find the following. Okay, now first one is you have to find the constant c. So for constant c, if you remember, we study a theorem that says that if we take the minus infinity integral f of x is equal to 1, so we use this one. So this implies that when I take the integral, this integral only defined from 0 to infinity from the definition, so this becomes cx and minus x by 2 d of x equal to 1. So when I solve this integral, so it becomes is equal to minus 2c x exponential minus x by 2 from 0 to infinity. When I plug in the and then plus, because there are two, so we have to integrate by parts. Okay, now for second one is from 0 to infinity again, 2c exponential minus x by 2 dx. Okay, when we solve this, so when we plug in infinity, so this is 0. When plug 0, this is 1. So this is 0, this part becomes 0. Alright, so for next one, when we do the manipulation, so it becomes 4 c exponential minus x by 2, 0 to infinity. When we put in the values, becomes 4c. As this is equal to 1, so this must be equal to 1. This implies that c is equal to 1 by 4. Now from here we calculate the value of c. Now the next question is that you have to find the CDF f x of x. So how to find the CDF? CDF is actually the integration. So if we apply the theorem, if you look at theorem 3.2, and it says minus infinity to x f of x, sorry, du. So this is the theorem. Now plug in the values. So we have minus infinity to x, and for this value is defined now from minus defined from 0. So remove this and write again from 0 to x. So c is 1 by 4. So put x exponential minus x by 2 divided by 4. Instead of x, you put u here. So let me rewrite this one. Sorry about that. It becomes u. Sorry, not x, u. It becomes u exponential minus u by 2 divided by 4 du. So you have to solve it using integration by parts. So this is equal to minus y by 2, not y, sorry, minus u by 2 exponential minus u by 2 from 0 to x minus, this is integration by parts, so you can do it, not a big deal. So it's become minus 1 by 2 exponential minus u by 2 du. Now if we do a little mathematical manipulation, so fx of x is equal to 1 minus x by 2 exponential minus x by 2 and minus exponential minus x by 2. So this is the answer. Now we can further rewrite it as fx of x is equal to 1 minus x by 2 plus 1 times exponential minus x by 2. This is only possible when x is greater than 0 and otherwise is 0. And if I sketch this, so this will look like something. It will start from 0, and this is x, so it will start from here and goes like this. This is 1. Okay, this CDF. Now the third part of the quiz is that you have to find the probability that 0 is less than capital X is less than equal to 4. So this is the third part. So how we go about it. So we can easily write using formula less than x is less than 4 is equal to f x of 4 minus f x of 0. So that becomes 1 minus e minus 3 power 2. Okay. So fourth part says that calculate the probability interval minus 2 is less than x is less than equal to 2. So it becomes fx of 2 minus f x of minus 2 as minus 2 is 0, so it becomes 1 minus 3 exponential minus 1. So this is the solution that we get for this quiz. Now after that we have to define a very important topic, and for this one is article 3.3, and it's known as expected value. How expected value look like for a continuous? So we have a definition that is 3.4, and it says that the expected value of a continuous random variable x is given as expected value of x, and you have to, due to continuous, you have to integrate it. If you have a discrete, then you sum it. So you do same thing, but here instead of PMF you use PDF and do the integration. So this will give you the expected value. Let's do an example here, 3.6, and example says that PDF given to us, that is 1 and 0, and x is less than 1 and with 0 and 0 otherwise. Now this is the question, and he is asking us to calculate the expected value. Now as you know that expected value is the formula from minus infinity to infinity x time fx of x. So because this is defined between 0 and 1, so our limit start from 0 1 x time PDF is 1, so dfx. So when we do that, this is x squared by 2, 0 to 1, just plug in the values, becomes 1 by 2. Let's move to next example. This is example 3.7, and it says that calculate the expected value of y, and okay, fy of y is given to us, and that is equal to 3y square, 0 otherwise. 3y square is between 0 and 1. Now just put in the values. So expected value of y is just solving an integration that is between 0 and 1, y times 3y square, so dy. So when we do it, it becomes 3 by 4. Now similarly another example 3.8. So the main idea is, if you know the how to solve integration, so you can easily find the expected value. So here it is 1 and 0, and this is between x and 1 and otherwise. Let a uniform random variable with PDF given to us. He says let w is equal to g of x, and that is equal to 0 if x is less than 1 by 2, and w is equal to g of x is 1 when x is greater than 1 by 2. Now question is W is a discrete uniform random variable with range SW is equal to 0 and 1. So without regardless of its value, so its expected value is calculated. So expected value of, sorry, let me rewrite here, g of x is calculated that minus infinity g of x times fx of x dx. So from here we have a theorem that says 3.4, the expression, the expected value of a function g of x of random variable x is of g of x of continuous random variable if x is expected value of g of x is equal to minus infinity to infinity g of x, sorry, small x, fx of x dx. So this theorem helps us to calculate the expected value of the derived random variable. Now the theorem 3.5, for any random variable, now random variable x, so we have this thing that this will follow in continuous as well, that if we take the expected value of mu of x, this is equal to 0. Similarly, if we take the expected value of a times x plus b, so this theorem linearity holds same as it was in discrete case. Similarly, the last one is that variance of ax plus b, so you know that variance is not following the linearity, so it becomes a square times variance of x. So these are the theorems. So with that theorem, so one thing we must know, that expected value of x square is actually minus infinity x square fx of x dx, or we can say that variance of x equal to, this is the second moment, and if we want to calculate the variance, so it becomes minus infinity to infinity x minus mu of x whole square fx of x dx. So this is the formula that we can use to calculate the variance. Now we will do the quiz and then we stop. So quiz is number 3.3, and quiz says that the probability PDF of random variable y is f of y is given to us, and that is equal to 3y square divided by 2 is 0, and we say it is between minus 1 and 1, 0 is otherwise. Now first one is calculate the expected value of y. So you know that expected value of y is from minus infinity y times f y of y dy. When we plug in the values and solve it, so it becomes minus 1 to 1, 3y cube divided by 2 dy. When we solve this, it becomes 3 by so 8 y power 4, and it is from minus 1 1. When we plug in the values, so it becomes 0. Now the second one, he is asking to calculate the second moment, that is y square. So it is again from minus infinity to infinity. Here is the y square, fy of y dy. So if we do that, so this becomes minus 1 1 3 y4 divided by 2 dy. So then it becomes 3 by 10 y 5 minus 1 1. When we plug in the values, so it becomes 3 by 5. Now the third one is asking to calculate the variance of y. So variance of y, as we know, that is expected value of y minus y whole square. So in that case, this is equal to 3 by 5. Now the last one, because the expected value is 0 square, so it is becoming 3 by 5. Last one, fourth one, is asking us to calculate the standard deviation. Standard deviation is under root of variance of y. So but it's very easy, just plug in the values here, 3 by 5. So when we, this is the result. So I will stop here and we will continue further in next coming video. Thank you.